¿Qué es la que hay, mi gente? Welcome to eCruz Learning, where it's just that easy. I'm your host, your favorite host, Master Cruz, and today we're going to talk about rate of change. So rate of change, aka slope, is the change in y over the change in x. And if we're graphing, you've probably heard this term before, rise over run. So today we're going to learn how to do this from a point, and we're also going to learn how to do this from a graph. So here's the slope formula. You need to know this. You need to memorize this. What you need to remember is the formula SM equals y2 minus y1 over x2 minus x1. It's very important that you remember that the y values are always on top and the x's are always at the bottom. The biggest mistake that I see people make is that they put the x values on the numerator. X's do not go on the top, x's go on the bottom, because to be quite frankly, nobody cares about the x. Your x should always be at the bottom. So M stands for slope. M equals this. And obviously, in order to calculate that, you need two different points. And just as a refresher, a point is always x comma y, x comma y. The first point is 1, 1, and the second point is 2, 2. So for example 1, we want to find the slope between these 2 points. How can we find the slope between these 2 points? Well, the first step is label the points. Do not attempt to do this in your head. It prones to confusion and to mistakes. So the first point is always x comma y. You just put 1, 1 because this is the first point. And the second point, again, is x comma y. And then you write 2, 2 because it's the second point. Make sure that every time you label a point is always x comma y, x comma y. All right, good. Now we're going to write the equation and then evaluate. What does that mean? Well, it means that I'm going to write this. I'm going to put my fraction bar, and hopefully you can see that there's minus on the top or at the bottom. So I'm going to write a minus sign on the top and a minus sign at the bottom before I start evaluating. And evaluating means replacing the numbers in here. The reason I do this is to minimize the amount of mistakes that I make when I write my numbers. So here we go. What's y2? Well, y2 is 11. So I'm just going to substitute 11 here. Minus, what's y1? y1 is negative 3. So because I wrote that minus, I know that I have to write a negative 3 in parentheses because I need a double minus now. Okay, because that negative 3 is different from this minus sign, which is also a negative, but they're two different signs. They're two different signs. X2, so that's x2. This is negative 5. Okay, and then x1 is just 2, so I write down 2. And that is my equation evaluated. So I evaluated my formula. Now I need to simplify. Every time that I have minus negatives, hopefully you remember what to do here. You need to connect them, right? So we're going to connect them because with the parentheses, you're going to make a messed up plus sign. So in reality, this says 11 plus 3. That's exactly what that says. That says 11 plus 3. So my next step, when I do 11 plus 3, that's going to give me 14 in the numerator. And in the denominator, negative 5 minus 2, same sign, add. So negative 7. And then you keep the sign of the higher number, but they're both negative. So the answer is negative. So 14 divided by negative 7, this will turn into negative 2. So that means that M equals negative 2, which that is the slope. If you're not sure why the 2 is negative, remember the 2 is not positive because we're not keeping the sign of the higher number. That's for adding and subtracting. Here, if one is positive and the other one is negative, the answer is automatically negative. You should use the triangle. And if you don't know how to use a triangle, please see one of my early videos on how to multiply and divide negative, positive, and negative numbers. I do want to make a very important distinction. The answer for this problem is negative 2. But what if these two were reciprocals? What if the negative 7 was on top and the positive 14 was at the bottom? So this is a completely different problem. This is not the same problem. But what if? Well, this is not negative 2. And I need you to understand that if the bigger number is in the denominator, your answer will still be a fraction. And what you do is that you reduce, divided by the greatest common factor. So here the greatest common factor is 7. because this is the biggest number that divides them both. So my answer is still negative. 7 divided by 7 is 1, and 14 divided by 7 is 2. So we are going to reduce the fraction, and we still get a fraction, not a negative 2. So remember that. If the bigger number is in the denominator, the answer will always be a fraction. All right, so you learn how to do this with points. Let's do it with a graph. How do we do this with a graph? Well, to be able to do this with a graph, there's two different ways. You could find points, or you can count rise over run. So first, to find a slope, you need 2 points. So when you look at this, what are 2 points that you know for sure? You know the x value and you know the y value for sure. So I have to be careful, right? I want to give you an example. If I'm looking at x's, and I look at this right here, I know the x value is 3, but I'm not sure what the y value is. So that point does not help me. If I'm looking at this one, I know the y value is 1, and I'm not sure what the x value is. So when I have a coordinate grid, I actually want to go like to the corner of the squares, because I know those points for sure. So if I draw a point right here, hopefully you can agree that that's a point that we know for sure. That's actually the point 0, 1, 0, sorry. And we also know this point for sure. If as I move along, I realize, ooh, I also know that point right there for sure. So I know these 2 points. So because slope is rise over run, notice that I didn't write the points to then use the formula. All I have to do is count. As I move from left to right on this graph, as we always do, because remember, when you read from left to right. When we write from left to right. So when we draw graphs or read graphs, we also do it from left to right. So when we do that from left to right, which point do we encounter first? I encounter this one first. So rise. Do I need to move up or down? Well, I need to move up. So this is going to be how many units do I have to move up? 1 unit up, 2 units up. So to reach from one point to the other, I have to move 2 units up. That means that if this is 2, then my rise up here is 2 over how many times do I need to run to get to the other point? Remember, I first move, then I count. First move, then I count. So I'm going to move once, I'm going to move twice, and I'm going to move 3 times. Therefore, this up here is 3. So my run to the right is 3. So my slope, the slope of this line is 2 over 3. Okay. Now, I need you to double check this. This is the slope. That's it. You're done. But how about if you get confused and you don't know how to do it? Well, you could label the points. This is the point 1, 0, right? And this is the point -2, -2, actually, right? This is the point -2. This is -2 over here. And this is -2 down here. So that's the point -2, -2. This is the point just 1. And we can move up or down, so it's 1, 0. If you use the slope formula with these 2 points, you should get 2/3 back. So go ahead and check it, see if you get that. The last thing that we're going to do, and you can ignore that, that is not the correct page. The last thing that we're going to do as example 3, okay, is this. Different types of lines. So I want you to think about all these lines. There's a bunch of lines over here. Which lines have a positive slope? Which lines have a positive slope? So there are lines in this one that don't have positive slopes. Remember, in order for something to be positive, when you move from left to right, you need to be going up. So the white line is a positive slope. The blue line is a positive slope. The red one from left to right, as I move along, it's going up. That's a positive slope. The yellow one, as I move up, that's a positive slope. The blue one or purple, whatever that is, this is not, because hopefully you can see that as I move from left to right along the line, this is going down. So I'm going to erase that one because that one is not a positive slope. And the green, you guessed it, that is not a positive slope either because it's going down from left to right. So all these lines, even though some are more steeper than others, they're steeper than others, they're all going up. Negative slopes. Which lines can you tell that are negative. Well, the dark blue one, the red and the yellow, they all have negative slopes because as you move from left to right, it is going down. The light blue is not, is going up from left to right. That actually has a positive slope. And the green one is also wrong. That has a positive slope. Out of all these lines, which slopes are zero? Well, as you look at this, none of them are increasing or decreasing. They're just horizontal lines. So the slope of the horizontal lines are zero because the word horizontal has two zeros. Can I spell correctly? Let's see. Horizontal has two zeros in it, right? It has two zeros in it. So you have this O and this O, which are zeros. And then if you look at this one, all of them are undefined. Vertical lines are undefined because it does not pass the vertical line test. It looks like the light blue one, it was trying to be vertical. I'm gonna erase that because that's not like perfectly vertical. I mean, not like they're any of them perfect, but you get the idea. They have to go down. And if you have a vertical line, that's always undefined because you cannot write rise over run. Every time you get zero, it's a horizontal line. So the slope of a horizontal line is zero, and the slope of a vertical line, it's undefined. All right, that's all you need to know about slope. And you continue to learn in your journey, but these are the basics. This is what you need to know for the slope, so you can find a slope from a line, from a graph, or from a point. My name is Master Cruz with eCruz Learning, where it's just that easy. And if you need additional help, please sign up for our Virtual Math Masters program so that we can help you individually and in a personal basis.